Hello everyone, my name is Toping and today I will be presenting the core consideration in selecting a suitable material for bicycle frame. This decision isn't just about choosing something strong, it's about ensuring the material can perform reliably under mechanical demands and real-world environment. Let's begin with the functional requirement. The bicycle frames must support the rider weight, typically between 70 to 100 kg, as well as force from pedaling, braking, and terrain impacts. This means the material must have high structural strength to prevent failure and sufficient stiffness to maintain handling and pedaling efficiency. In addition to strength and stiffness, the frame experiences cyclic loading caused by continuous pedaling, road vibration, and minor impacts. Over time, this load can lead to fatigue damage, especially at high stress zones like joints and wheels. Therefore, fatigue resistance is essential to maintain long-term structural integrity and rider safety. Another critical requirement is weight. Lighter frames offer better acceleration, climbing ability, and handling. However, we must balance low weight with sufficient strength and stiffness. This is where materials with high strength to weight and stiffness to weight ratios become ideal. Corrosion resistance is also a key functional requirement in bicycle frame design, especially for bikes used outdoors or in humid environments. A frame that resists corrosion lasts longer and maintains its strength and appearance over time. Without it, rust can weaken the metal, leading to structural failure and safety issues. Materials like stainless steel, aluminum, or surface treatments like anodizing or coating are often chosen to protect the frame from environmental damage and ensure long-term performance. Next, geometry integrity. It refers to the frame's ability to retain its intended shape and alignment under various loads during use. Even minor deformation can negatively impact handling, rider comfort, and overall performance. Hence, it plays an important role in preventing stress concentration, which can lead to fatigue failures over time. Last functional requirement is manufacturability. It ensures the selected material can be efficiently processed through forming or shaping methods like extrusion, welding, or hydroforming. Good manufacturability supports dimensional accuracy, consistent quality, and production scalability, all of which are necessary to meet both performance targets and practical constraints like cost and lead time. Next, let's move on to the service environment. First is mechanic loading. The frame experiences mechanic loading in the form of bending, torsion, and impact forces, especially over rough terrain or during aggressive riding. These stresses often concentrate around the joints and must be managed without structural failure. Second, the bike is exposed to a wide range of temperatures, from as low as -10 Celsius to above 50 Celsius in direct sunlight. Fluctuations like this can cause expansion and contraction, which may affect joint stability and material performance over time. Third, moisture is an ever-present factor. Exposure to rain, sweat, and road salts, particularly in humid or coastal regions, can cause deterioration, especially if the frame is used frequently or stored outside. The frame also endures continuous vibration and repeated impacts during regular use. These forces can gradually cause microcracks and internal damage if the material lacks fatigue durability. This is particularly important for riders who use their bike in off-road or highly stressed conditions. Lastly, long-term exposure to UV radiation, especially from sunlight, can degrade surface finish or coating, and in some cases, affect the base material itself. This could lead to fading, surface crack, or long-term weakening, which must be considered in the designing phase. As a conclusion, material selection for bicycle frame depends heavily on two main areas: functional performance and service environment. A thorough understanding of these factors ensures the selected materials can provide safe, long-lasting, and highly performance use under realistic conditions. Thank you so much for your attention.
My name is Aris Jawhari Benzabidi. Today I will be presenting a comparative study of 4 key materials used in bicycle frame construction: aluminum alloy, chromoly steel, titanium alloy, and carbon fiber reinforced polymer, or CFRP. The presentation is divided into 2 parts. First, we will compare the mechanical and performance properties, and then we will look at manufacturability and recyclability, which are equally critical for real-world application and sustainability. For part 1, material property comparison. Aluminium is widely used due to its low density, giving a lightweight frame. It has moderate strength and stiffness, and its fatigue strength is improved with heat treatment. It also offers good corrosion resistance, especially when coated. This made it a good all-rounder material for general purpose bicycle. Chromoly steel is much denser, so it results in a heavier frame. But it offers his high strength, very high stiffness, and excellent fatigue resistance, perfect for rush and long distance use. It lacks natural corrosion resistance, so it requires coating. However, it's known for durability and strength under stress. Titanium alloy provides a unique combination: medium density, high stiffness, exceptional fatigue, and corrosion resistance. It's very comfortable to ride due to its vibration damping properties. However, it's expensive and typically found in premium long lifespan frames. CFRP stands out with very low density and extremely high strength and stiffness, but primarily in the fiber direction. It has excellent vibration and corrosion resistance, but low fatigue strength across fibers. CFRP is widely used in racing due to its lightness and stiffness to weight ratio, so it's delicate and costly. 2. Manufacturability and recyclability. Manufacturing comparison. Now, let's look at manufacturability. Aluminium is easy to form using extrusion or hydroforming, and is highly weldable using TIG welding. It's great for mass production. Chromoly steel is also easy to bend and wear, but more suited to custom or small batch builds. It's also easy to repair. Titanium is difficult to machine and weld, requiring special tools or skilled labor. This limits it to low volume or custom production. CFRP is the most complex. It involves manual fiber layout and carrying in autoclaves. It's labor intensive and expensive, and very sensitive to manufacturing defects. Thank you, that's all from me.
My name is Agiram. In this slide, I'm going to explain about the sustainability and recyclability of the four material that we try to review for our bicycle frame. So the first material is aluminum alloy 6061 T6. So the advantage of the material is highly energy to produce, but recycle use only 5% of the energy. Excellent recyclability with minimal property loss, and then well-established global recycling infrastructure, and good sustainability rating due to low end of life impact. And then the second material is chromium steel AESE 4130. This material is lowest embodied energy and CO2 emission among the material. Most recycled engineering material globally, and then durable and easily repairable, support long service life, high sustainable, especially for utility and touring bike. The third material is titanium alloy Ti6AE4V. Very high energy consumption and carbon emission during production, and then recyclable in theory but limited infrastructure and high purity requirement. Pure processing sustainable despite long material lifespan, moderate sustainability overall due to cost and complexity. Then the last material is carbon fiber reinforcement polymer CFRP. This material is very high embodied energy and emission, especially for epoxymetric. For recyclability, thermoset resin are not removable. Most waste of the material is go to landfill or downcycle into low value product. Low sustainability rating despite excellent performance. This is our last slide. In this slide, I'm going to explain about final material selection and justification. Here we select aluminum alloy 60 and 61 T6 the advantage of the material is in terms of good strength and stiffness, even though the strength and stiffness is lower than chrome steel and titanium steel and then titanium alloy, but in terms of strength for bicycle frame is sufficient enough. And then in terms of the cost effective to produce this material is very competitive compared to the chromium steel and also titanium alloy, because the available of aluminum is a lot, and also the price is quite competitive compared to the other. And then highly recyclable. The aluminum alloy is giving almost zero waste, so almost all the aluminum can be recyclable and can be used again. And then in terms of the lightweight is aluminum alloy is very good, because if we compare to the carbon fiber polymer reinforcement is lower performance, and also carbon fiber is lighter, but aluminum alloy is can be used, and this material also lightweight, and then excellent manufacturability. This material is easily to produce, and also to produce bicycle frame using aluminum is not too hard to manufacture bicycle frame using aluminum alloy. Thank you.